A warm welcome to all of you. Thank you for taking time out of your busy schedule to attend this webinar series. My name is Akash Sharma and I work as a technical support engineer for MIDAS Research and Development India. And today we will be talking about Introduction to GTS NX for Geotechnical Finite Element Modeling and Analysis. Basically, a basic introduction to the software, what are the capabilities of the software, and then we'll be talking precisely on how exactly GTS is efficient while dealing with tunnels. I will demonstrate today the various options which are available with GTS NX. Once we are done with our first session, as you already have received the email, the second session will be taking on a complete modeling, the third one on 2D versus 3D modeling, what are the advantages, and the final one on influence of tunneling on nearby structures or effect of constructing a new structure nearby existing tunnel. So this is the basic brief summary about the webinar series. So to start with, let me give you a brief introduction to the product. So GTS NX is a completely 3D, 2D as well as axisymmetric finite element analysis software which can be used for all kind of geotechnical applications. It has its own pre and post engines and a very powerful solver. It has been optimized for 64-bit platform and can be used efficiently and effectively to deal with any large-scale modeling. So talking about the interface, GTS NX provides you with a multi-window interface. For example, if you are working on one window, you are running some sort of analysis and simultaneously you want to work on another window, you can just say file new and open 2 to 3 windows depending upon your RAM configuration and work simultaneously upon them, which helps you save time as well as increase your efficiency. So geometric modeling, the simulation of field conditions. So GTS NX has a very strong geometric modeling input and very easy to deal with complex problems. You have all the basic commands which are used in day-to-day AutoCAD like extrude, sweep, trim, divide, Boolean operations, which can be easily used to create any sort of complex geometry. So we'll be today I'll be showing you how exactly it can help you create complex geometries and how we have incorporated various advanced and automated commands. Okay, so the next slide, as it reads, it says that automated modeling functions. So we came up with the options like auto imprint and auto connect. For example, just to highlight what exactly it is. For example, if I have one solid and another is the biggest solid and I want to cut the inner solid out of the main solid, what I use is the option called Boolean operation, right? I just cut the inner solid out of the main solid. But what happens when we deal with problems, especially like tunnels, we have 100, 200 solids, which are basically the excavation sequence. So we cannot go and performing Boolean operation each and every time. So what we do, we came up with the option called auto connect. You just select all the solids and perform the auto connect operation. The program will automatically cut the inner solid out of the outer solid. So it's true with imprint points. For example, you have nails supporting your tunnel excavation. So as you know that proper finite element analysis takes place when there is a node-to-node connectivity, correct? So what happens is that to make sure that the curves are properly imprinted into curves, we have the option called auto imprint, where you just select all the solids and all the curves. The program will automatically imprint and take care of the nodal connectivity. So these are the automated functions, which today I will also be demonstrating you, which will give you a better idea of what exactly this automated function can do. So moving on, generation of 3D topography layers. So this is the features, we call it as TGM, Terrain Geometry Maker. So if you have an auto TXF contour plot of any area, you can use TGM to create the surface which represents the undulating or the variation of on the topography of that particular area. So this becomes very important when you have a slope stability problem or a dynamic analysis where you want to consider the exact variation of the top surface profile. So it can be easily encountered with the help of TGM, or what we call as terrain geometry maker. So generation of 3D topographic layers. So when we have taken care of the top profile, the next question which comes to mind is how exactly the subsurface profile are varying. So if you have the borehole log data, for example, as you can see on the screen, you have borehole 1, 2, 3, 4, 5. So if you have such input data, you can just use the bedding planes data. The program does a simple mathematical interpretation and it gives you the varying surface for each of the soil layers, which can be then used as a cutting tool to cut the solid and create the solid geometry. So moving on to soil structure interaction. This is very important part, especially when if you are dealing with pile foundations or any kind of foundation. So what happens is, as you know, MIDAS has the products in the field of buildings and general structure known as MIDAS Gen. For bridges, we had MIDAS Civil. Okay, so it has compatibility with CAD, wireframe, 2D and 3D, DXF, DWG formats. You can import it directly. But what happens is the intercompatibility with the other MIDAS software like Gen and Civil. Let's suppose if you have a building created in MIDAS Gen, you can directly import the building into the software, which helps you get the dead load and live load directly into the program. You can model the foundation here. So with the column locations helps you determine the pile location as well. Model the pile, model the raft with the soil continuum, and you will be able to get what exactly is the settlement or what is the differential settlement one is going to expect. So the intercompatibility of the software helps deal with the soil structure interaction problem more easily and efficiently. This is what I was talking of. So you have a building, you bring it in GTS NX, create the foundation here. You have a bridge, bring it in the software, and you can model in GTS NX directly. So advanced meshing tools. So MIDAS GTS NX provides you with various meshing options. Let it be a 2D, 3D, or we can say 2D auto mesh, excuse me, 3D auto mesh, 3D map mesh. Okay, even you can consider a size control, and then you have the options of creating the 2D mesh frame, and you can extrude it into the solid. So all kind of meshing option with manual control of course is present in MIDAS GTS NX. So moving on to the next slide, hybrid met with hexahedral elements. So if you are dealing with tunnels, you might understand the difficulty in extracting the shell element forces modeled with the help of tetrahedron elements. Okay, so MIDAS GTS NX provides you with both the option. You have tetra measure as well as the hybrid measure. Now with hybrid measure, the thing is, if you think of a 2D plate element, what the basic element is a rectangle. So aligning the coordinate system, the element coordinate system, especially for plate when you model a wall or lining, becomes more easier, and also the contour which we get with hybrid elements becomes more effective, especially while dealing with tunnels. The hybrid mesh provides you an advantage over tetra measure. So MIDAS GTS NX provides you with both the option. You have the tetra measure as well as the hybrid measure. Okay. So with loading options, so you have all the static loads as well as the dynamic loads. You have self-weight, force, moment, displacements, all which are required to model any kind of load in the program. Then you have the dynamic loads, response spectrum, ground acceleration already inbuilt, 52 earthquakes are already there. Then we also have blasting load data. Okay, so if you, as you can see on the screen, as per various institutes like National Highway, International Society of Explosive Engineers. So when you input it in the visit, the program automatically generates the blasting load. So if you want to perform the blasting load analysis, you can take this load directly, apply it, and you can see this effect on nearby structures, or any kind of analysis, time history analysis you can perform using that load. Okay. Then you have automated live load data. So if you have train dynamic load table, this is a feature where you just input the length of the train velocity. The program automatically generates a dynamic load for you. So you can see, or you can study the effect of high-speed train moving on your embankment. What is the effect of the same can be studied using the automated live load data generator. So what kind of analysis can be performed in the software? So I'll start with slope stability analysis. So GTS NX provides you with the option of C-phi reduction, commonly known as the strength reduction method, SRM. So you can consider the construction stage with uh, strength reduction method. SCM is basically a 2D type of analysis where you have a grid and the factor of safety is calculated using the stress analysis. So as you know that construction stage analysis becomes very much important, especially while you are cutting or when you are filling. So with each stage you can get factor of safety. Then you have dynamic analysis. So you can perform linear time history analysis, non-linear time history analysis, eigenvalue response spectrum. Then we have coupled analysis. So with MIDAS you have a coupling of two types of analysis. For example, in this case we have nonlinear time history plus SRM coupled. So what happens is, for example, you are performing a time history analysis, let's suppose due to an earthquake, and you want to see that what is the stability of my embankment or the dam which you have designed against slope failure. So what you do, you run the time history analysis, and at any point of time you can ask the program to check for the slope stability. So for example, if the earthquake duration is 6 seconds and you want to check at 3 seconds what is the factor of safety, can be checked against C-phi reduction method. Please note that here we are not applying the load as a pseudo-static force. It's a completely dynamic analysis considering nonlinear time history. Then you have seepage analysis, so steady state as well as transient state. You have water, you want to see the phreatic line diagram or the flow line, you can check that. Stress seepage fully coupled, once again, many times what happens, same, I will take example of an embankment. You have water on one side, but and dry on the other side of an embankment. Due to seepage, there will be some part will be saturated. So what we do, we sort of couple two types of analysis. We first perform, let's say, seepage analysis, which gives an idea of how exactly the seepage is going to take place, where we are going to have the pore pressure distribution, and then we run the slope stability analysis. Okay, so you can also perform a simple stress analysis to study the effect of seepage. Then you have consolidation analysis. Okay, well, if you want to see the long-term settlement due to consolidation, can also be studied. Now, as you all know that whenever we deal with geotechnical problems, it becomes very important to consider the construction stage, because each stage is going to affect the next stage, whether it be tunnels, whether it be pile drive foundations. So you want to simulate each of the analysis in construction stage, and GTS NX provides you with the option to perform all the analysis, be it slope stability, construction stage, or coupled analysis, considering construction stage analysis. So these are the various type of analysis. So one question always whenever you are going to check any geotechnical program, what are the material models there to simulate the behavior of rock and soils? So on the right hand of the presentation, it's a latest screenshot from the latest version of GTS NX. So you can find that almost all the standard material models like elastic, Tresca, more column, hardening soil, small strain, all kinds of material models are available. Even if you see the latest material model for tunneling like CWFS, cohesion weakening, friction strengthening, is also been recently incorporated in our latest version of GTS NX. Okay, and also many times, as we can all agree that maybe sometimes this material models might not be enough to simulate the real field condition. So you have the options of writing your own material model code using Fortran language. We call it as user supplied material, and that can be used for analysis and simulating the actual ground behavior. Okay, so there is a flexibility also in the program to add any material model if you want on your own. So next, element library. So you have truss, embedded truss to model nails, you model anchors, you have beam, you have pile elements. Then you have a geogrid, shell elements like plate element, gauging shell. It's a kind of element. For example, you have a raft and you model it as a solid element, but the end you want to see what is basically the bending moment or the axial force diagram on the raft. So it's a gauging shell is basically a type of element which takes the stiffness of the solid and gives the output in form of axial force and the bending moment diagram as in a plate element. Okay. So then you have 3D, so of course solid modeling, and also you have interface elements and various kinds of links to deal with various kinds of soil structure interactions as well. Okay. So this is about the element library. Easy control options, few options. Now you can see in the figure that there's a swimming pool kind of a situation. So you have a water level and you want to apply the water level directly. Now this is, I'm talking of the external force. The internal force is automatically considered when you have defined the water level. Now external force, you can do it manually for such cases, but you have an option of automatically consider the water pressure. So the program will automatically apply the load externally onto the existing faces. So for this, one can say that we can easily manually calculate, but the problem comes in a situation like this. In the next slide, if you see that when you have an excavation, calculating for each phase becomes a tedious work. So just an option and the program will automatically apply the external load for you. So moving quickly on to the post-processing tools. So we get a graphic based output. So you have the contour plots, you have the options like flow diagram where you can see with animation how exactly in case of seepage the flow is happening. You have the options to moving to 3D to 2D at any particular section you want to check the results can be done. You have the options like cutting plane diagram to see the behavior of a particular plane. Okay. Then options like probe, at any point of time you can select any node, no predetermination of node. You can select any node and you can study the behavior with construction stage. You have the options like extract where you can take the results in a tabular form into Excel or any format. From Excel you can just even you can plot the graph in the program itself. Okay, so these are the various options. 3D PDF report. So if you have some as you know that finally we have a contour plot and you want to take an image, we have also image directly. You can take the screenshot with the help of program itself. Also you can take the model into PDF, rotate it the model in PDF itself, probe and save in the PDF itself. Okay, so this is about extraction tools. So project applications, slope stability, so 2D, 3D, axisymmetric, any kind of problem with construction stage, without construction stage can be handled in the program. So few tools which becomes very important when you talk about slope stability, like you have the TGM, terrain geometry maker. Many a times a 2D problem cannot simulate the actual field condition. So this helps you understand basically if you have any local slope failure. Construction stage analysis, as I already mentioned. Then you have various tools to model the geogrid, the nails or the reinforcement which you are considering to check the effect on slope stability analysis. So foundation, so pile drive foundation, one of the big aspect of using any 3D finite element software. So the CAD compatibility with the other MIDAS software provides an edge to GTS NX while dealing with pile drive foundation. Excavation and temporary structures. So if you want to do an excavation or some shoring and you want to see what is the effect on nearby structure or what is the effect of your shoring on the displacement or what is the actual force coming in your reinforcement can be checked and analyzed in the software easily. Another application of 3D finite element software. Soft soil embankment, so once again consolidation, if you want to check what is the long-term consolidation after 1 year or 2 year, can be studied and analyzed. Hydraulic and underground structures, one of the most applicable areas when we deal with hydraulic and underground structures. All types of analysis, whether it be seepage, you have slope stability, you have construction stage, also dynamics at times comes into play when you deal with such problems. Now we'll come to tunnels. Tunnels is a very important part whenever you deal with the 3D finite element analysis software. With tunnels, the application areas can be designing of a tunnel. When you are tunneling, what is the effect on nearby structures, which is becoming a very important problem when you talk about many countries where you have existing cities, and now they are going to develop the tunnels, or there are existing tunnels and they are going to construct nearby some structures, whether it be some building, hotels, or bridge foundations. Okay, so this study can also be done with the help of finite element analysis. If you want to check the stability of the reinforcement you came up with, the type of construction method, or the way you are going to construct, all can be analyzed and designed in the software. Okay, once again, by design here I don't mean the reinforcement, but what will be the actual thickness, what will be the layout, what is the apt location of your nails, and what can be the depth in case you are now going to construct a new tunnel. Okay, so all can be analyzed. So today my prime focus will be to show you how exactly GTS NX provides you with various options to deal with complex GTS problems. Okay, so let me go to the next slide. Now we'll talk about GTS NX, what are the various tools, and how exactly it can be used in the program, or how effectively can it be used for tunnel problems. Okay, so what are the modification, or what are the advantages one can have while dealing with the tunnel problem, especially with GTS NX. So first of all, you have inbuilt standard section with rock bolt arrangement. Of course, you can import a AutoCAD file, but here you have all kinds of like 3 center circle, 3 center circle plus invert, 5 center circle, and 5 center circle plus invert kind of arrangement already there. You have a circular arrangement as well. So there are inbuilt standard sections which can with rock bolt arrangement. So you need not take much time to do it in AutoCAD. You can directly start modeling in the program itself. Okay. Then geometric commands like extrude, translate, sweep, divide helps you dealing with any complex geometry. Auto connect and auto imprint are advanced tools. Okay. Now let me demonstrate this feature so that you can understand that how exactly one can take on complex problem more easily. So I'll move on to the program now. So just say new. So first of all, I'll just make familiar with all of you with the working environment of GTS NX. Fine. So initially, when you start the program, ask what kind of model you want to start with, 3D, 2D, or axisymmetric. Anyways, we'll be taking the modeling in detail just to make you understand the working environment. The big frame with the coordinate system at the center, we call this as working window. And then on the left hand side, you have the works tree window where you can, whatever you create goes on to the left hand side. So if you want to edit, you want to hide the view, you want to delete something, just you can go to the left hand side. The bottom part where I'm just clicking right now, we call it as output window for any errors or the results complication. The top bar, which is divided from left to right workflow, geometry, mesh, static slope analysis, and results. All the commands can be found over there. Okay, so you don't have to search around the software. Just you can go from left to right and you can complete one model. Okay. So first of all, what I was talking was, for example, I want to use any basic command. So whenever you deal with any problem, what in GTS NX we suggest is that you create a 2D profile and then you think of the 3D. What I mean to say is just think of the best simulation in 2D for your problem. For example, I want to create a simple tunnel. So I just want first of all a rectangle for my outer soil model 0, 0, and then I say 20, 20. Let's say 40, 40. Okay, so my working plate right now is XZ, so it automatically creates a rectangle for me. Okay, now what I was talking was the inbuilt tunnel section, various kinds of inbuilt tunnel section like 3 center. These are the various types, left half, right half. Okay, you can consider that. Then what is the, and you can directly consider, let's say 4, 4, the radius. And if you want to include some rock bolts, you can simultaneously check as well. Okay, let's suppose I have 7 rock bolts and uh, length of 4 meters. Let me redefine it. Okay, 7. Length you can also define 4 meters or 3 meters. What is the tangential pitch? So here only you can define the arrangement. Then you can give the location. I'm moving it to the center. Let's say 20, 20. Say OK. Fine. So you have the rectangle modeled as wire. You have the tunnel modeled as wire. And then you have the edges modeled as then you have the nails modeled as edges, right? Now we just need to extrude it. Now command like extrude, select the target object. So whatever you want to select in the software, it works or goes by the selection filter. So I'm making it basic. So just select it, select the direction, what length you want, let's say 40 meters, preview it. So the direction is good enough for me, say apply. Similarly, select the target object, make it basic, select the wireframe, say preview and say OK. Fine. Now what I'm doing is I'm just selecting it and I'm hiding. Now I want to divide this solid because let's suppose it's a 40-meter solid and I want to excavate 2 meters. Okay. Now I want to divide the solid, right? So you have command like solid divide. Now let me show you. So solid divide. So what it asks for is it asks for a solid which we already have and then the tool surface. Now we don't have any tool surface, right? So let us create one. So rectangle, now I'm not making it as a wireframe. You have the command make face. Any rectangle size greater than the size of the tunnel. Then we say command like translate. Okay, so translate. So it's a very important command. Select the target object, the face, select the direction. I want to make a copy. So even, uneven, anytime, uniform, non-uniform, I mean. Let's suppose distance is 2 and number of times is 19. Preview it. Say OK, good enough. Now I just want to divide the solid with the help of this solid. So solid divide. Select the solid. Now select the tool surfaces, right? Now I have to select manually or I can select it. Now selection by intersection. The commands make it more easier to work with. Say select by intersection. Just select this faces. So all from the front view, everything gets selected. Delete the original. Yes. Delete the tool. I don't want the surfaces after that. Say OK. Fine. So you have your solids created. Fine. Now let's suppose I want the nail location at the center of the excavation. So once again, I just need to translate it, right? Say translate, select the object. I can go to front view, still the select by intersection. Select the direction. So it's a 2 meters. So I'm just moving it first by 1 meter. Okay, fine. Now I can just make a copy of it. Say translate, select the object, select the direction. You want to make a copy. Distance is 2 meters. Number of times is 19. Preview it. Okay, fine. So as simple as that, you can take care of the arrangements. Now, one very important part, still if you see, we have 21 solids and the outer solid is completely independent of the inner solids. What I mean to say is basically, we need to cut the inner 20 solids out of the main solid. So either I do Boolean operation, I do it one by one. I select one solid, cut out of the main solid. Or you have the options like auto connect, which I was talking of. You say Boolean Just say select all and just say OK. Fine. Now if I hide the inner solids, you can see the outer solid, it has just cut the inner solids out of the main solid. Okay. Now next thing is imprinting. Okay. Now what happens is that we need a node at this particular location so that we have a proper stress transfer onto the nails. So we have the option called imprint and we have auto imprint. So select the target objects, just select all the solid and then select the tools. I can hide all the solids. So this is the advantage. You can see the workstream window. You can easily hide, unhide things. Select by single or select by rectangle. I'm just selecting the 140 nails and just say OK. Fine. Now if I activate the inner solids, the program will show you a point created at that point. Now this point is nothing that a node will be created, whatever mesh size or whatever type of mesh you select, it will be created. At a node will be created at that particular point, ensuring the proper stress transfer. So this is the advantage when we talk about uh, different modeling commands available in GTS NX. Okay, so moving on to the presentation. Next is in addition with tetramesher, hybrid mesh is effective in case of tunnel. First of all, it provides you with more structured mesh. Okay, and second of all, that the alignment or when you want to align the coordinate system of the shell element, it becomes more easier. Okay, even the contours which you get from hybrid mesh are more structured as compared to the tetramesher. Also, tetramesher has its own advantage of dealing with complex shapes like bent shapes, but hybrid mesher becomes more effective while you deal with the tunnels, correct? So let me show you the various meshing options. For now, I'm just hiding the curves, say mesh, 3D mesh. Okay, now let me just show you the material. Okay, so material, you have isotropic. So all these material models are available with GTS NX. So you can just define one material for the soil. In this case, I'm just taking the default parameters and let's suppose some elastic material. Okay, I'm just taking some values just for demonstration part. Let it name this concrete, maybe say okay, close it. Then you need to define the property. So let's suppose we have 3D. So all our soil mass is modeled as 3D. Then you have 2D. So these are the various options. So I'm dealing with plate. This is basically for lining. I'm taking the line thickness as 0.3 meters. Fine. Now let me mesh the model for you. So mesh, 3D mesh. So once you have performed the auto connect, you need not take care of the nodal connectivity. Let's suppose I'm giving it a size of 0.5. So here you have two meshes, tetramesher and hybrid mesher. Completely depends on your assessment which kind of mesher you want to give. I'm using hybrid mesher. Say I'm naming it as excavation. Just writing EX, say apply. So it will be meshed and now one more question comes to the mind, that how exactly the construction stage definition can be tackled in case of GTS NX. Because what happens when you have uh, till now I have just modeled 40 meters, right? It can be 100 meters or 200 meters. How exactly we can deal with it? Okay, so I will be showing you. First, let's just mesh the solid. So once again, 3D mesh. So even if you give the outer solid a different size, you need not be worried unless you keep the measure same, of course. You just give it a name, main ground. Just say okay. So hybrid measure gives you hexahedron elements. So it gives you more structured mesh as already discussed. Okay, let me just go to the presentations for now. So next thing which comes is renaming of mesh set is very important and very easy to do in GTS NX. I will show you the importance now, how exactly it is very important. Then extract function. Now when you extract a shell element or when you create a plate element, it's very important that it has a proper nodal connectivity with both the solids, right? It is sharing its face with uh, the excavation solids as well as the main ground solid, correct? So the extract function in GTS NX helps to deal with it very easily. And then comes the stage definition wizard. I will show you how one can manually define the stages and how with the help of the definition wizard one can easily take into account the various stages. Let's suppose even if you have 100, 200 stages, within few seconds you can define it, the whole construction stage. Okay, so let me just move on to the program. I think the meshing would have, so it is taking some time. I'll just try to remesh it. I think I gave it, just select the size and give it size of 2, hybrid measure, and let's say main soil. Say okay. So once the meshing is done, I will show you that how exactly the nodal connectivity is also taken care of. Okay, so whatever mesh size you give the inner excavation a size of 0.2, you give the outer solid mesh size of, let's say, 4 or 5. So what happens many times is that if you don't perform the nodal connectivity, the nodes will not be properly connected. So with options like auto connect, it works like a check. You just perform the auto connect. The program takes care of the solid connection, that they share a common face between the solids, and then the issue completely is onto the program, that whatever mesh size you give afterwards, you give the inner solid a size of 0.2, outer solids a size of 2, the program will automatically take care of the nodal connection. Okay, so that can be easily taken care of. So I will just demonstrate you the function. I have already created one model so as to save some time. Okay, so this is already meshed model. Let me just show you. So this is how your model is going to look like after meshing. Okay, so now first thing which comes to mind is how exactly we are going to uh, basically create the mesh shell element. Okay, so I'll just show you. So the shell elements are already there in this model. I'll just, let's suppose, delete them. Fine. So we have an option in GTS NX. For example, this is my solid. Okay, now please remember that this is the solid, not the mesh set. Okay, I'm hiding the main solid. It's already meshed. Please note that extract function works only when you have meshed the solid. So you go to mesh, you go to extract, you select the face. Okay, now automatically the property has changed to shell. So whatever thickness which you have given, select all. Okay, now you can see it's 120 faces. So the outer faces are the places where we have the shell or the lining, but we don't want the inner faces which are in between the solids. Okay, so we have select unselect mode. Let's say select by intersection, going to the front view, and I'm just clicking or unselecting the inner faces. Registered based on the owner shape, just give it a name, shell, and just say OK. If you hide it, so the program has extracted the mesh set. So if you see with hybrid element, what you get is more like a rectangular element. So if you want to align the coordinate system of the shell plates element in one direction, it's more easier to do. Fine. So this is how basically you can take care. So this is already meshed for us. So I will repeat this step again so that it becomes more clear. So you have all the solids. So you can extract it with the help of solid once you have meshed it. Say extract, select the face, select all, registered based on the owner shape. Now please note that we don't want to select the inner faces. So I'm going to unselect mode. So this command makes it very easier to work. Unselect, select mode. Just give it a name shell. Say OK. Sorry. If you hide the solids, so this is the extracted mesh. Now the best part is it is extracted with the stages. Shell 1. Okay, now the problem is with the naming. So that's what I was talking of. Renaming is very important if you are going to use the construction stage wizard, because when I'm defining the construction stage, I should know which one is shell 1, shell 2, shell 3 in a proper sequence. Okay, so let me show you rename. Say rename it, select the object, say select all. Select the direction. So this first direction will decide in which direction you are going to name it. Ascending means it will start from 1 and then it will go on increasing in the positive y direction. Just say OK. Okay, so if I just sort by name, fine. So if you see shell 1, shell 2, shell 3, so I need not be worried about the naming now because it's being taken care directly. Similarly, I will name the excavations so that I can deactivate or remove it in a proper sequence. Say rename, select the object, select all, y direction, and I'm naming it as EX. Say OK. So excavation 1, 2, 3 will be properly taken care. Fine. Now let me show you how exactly the construction stage is defined. So this is our complete model now. We have a simple tunnel and the outer solids, and then you have the inner shell elements. So static slope analysis, you have stage set. So you can say stress analysis at. So in GTS NX, this is how the construction stage wizard definition looks like. You have all the mesh sets which you have created on the left hand side. Activated data, for example, you are activating something, you have to drag and drop in the activated data. Then deactivated data, if you are removing something, for example, you are removing some part of soil, so you will put that mesh set in deactivated data. Now we have 20 stages, right? So what happens, manually deactivating each of them and activating each of the shell element becomes a bit difficult. So GTS NX provides you with the option of stage wizard. Fine. So for example, I'm saying mesh set. So first is excavation. So that's why renaming becomes very important. What I'm doing is I'm removing it. Okay, so R stands for removal. Start from 1 and end till 20. Just a second. It's to 0. Okay, so postfix increment is 1. Stage ID first from the start we are going to remove. Similarly for cell element we are going to add it. Okay, so from 1 to 20. Sorry, just a second. To 0 till 20 stage. Then you have 1 start stage 1 increment 1. Okay, so this is my basically rules. Now first stage I will activate all the excavation, all the main soil. Okay, so if you have boundary condition and self-weight, that can also be activated. Okay, now just to show, if I say OK and if I simulate the stage, automatically the program has defined. I will just hide the main soil so that you can see. So you can see that the soil is being removed and simultaneously the cell is activated. So with stage definition wizard, any complex geometry can be easily modeled and the construction stage analysis can be easily defined for. Okay. So this was about the renaming part, the extract functions, and the stage definition wizard. Moving on to the presentation. Finally, when we talk of the post-processing tools, you have tools like cutting plane diagram, especially when you want to see the axial force diagram or the bending diagram with the plate element. You can directly use this diagram, because if you see that, you will find a contour plot as in seen in the left figure, but what you expect is a bending moment diagram as shown in the right figure. So with options like cutting plane diagram, it becomes easily to extract the results. Then tunnel modeling wizard. Okay, so let me just go to the program to tell you what exactly it is and how it can be useful. So I'm just opening a new window. So tunnel modeling wizard is basically if you have a very standard type of tunnel, of course. So what you can do is you can use this wizard to directly create the whole model within few seconds. Okay, let me show you. For example, tunnel, let me import the material property first. So already I have defined same. I have a shell element and I will not take the nails. Even if I do, I'll just not use it. Say okay, close it. Fine. So let's suppose you go to tunnel modeling wizard. In this static slope wizard, you have the tunnel modeling wizard. So it's a wizard where you start from left to right and you have a complete model with the construction stage definition ready for you. It shows you the type of tunnels you are going to have: circular, 3D, 5 center circle. What is the material property, of course? What is the radius R1 and R2? Fine. So whether which kind of excavation method you want to perform, full face cut, or you have other options where you can use it. Fine. So we'll go with, let's suppose, full face cut. Okay. Then you have other options as well, like bench cut to ring cut, other methods which can also be considered. Fine. Then you move on to the next part where you define the shotcrete and rock bolt property. So you have the shell, even you can consider the shaft as well as the hard shotcrete property. So if you have nails, what is the length of the nails? Okay. Then you move on to the excavation part. So how exactly you are going to advance for the excavation, one direction or two direction? Let's suppose if we just consider the model what we have been considering. Sorry, it will be 40 at the rate 2. Okay, automatically you can see that the nails have been placed at the center. So even if you want to change the angle, you can directly change it from the tabular format, making it user. Okay, then finally the mesh definition. So if I'm just considering there is no terrain and strata, it's a single homogeneous. So what is the depth? Let's say 40 meters. So 1.5 times the depth. Basically the geometrical dimension. Okay, what is the mesh size you are going to consider? Okay, let's say 0.5 times for the tunnel, 4 times the tunnel mesh. Okay, and you just say okay. So what we did, we just started what types of model we are expecting, what are the shotcrete and rock bolt, what is the excavation procedure, and what is the mesh. So just say okay. The program will automatically create the whole model for you. Okay, so you will see with all the boundary condition, you have the ground, you have the rock bolts, and even if we see, if I just simulate the stage for you, it has defined the whole construction stage for you. Okay, so whatever length, it's like 43 stage, you can see that how exactly it is being defined. So if you have a very standard type of tunnel, or if you want to just perform a basic analysis to understand the behavior, you can directly use the tunnel modeling wizard, which helps you understand the problem better and in an effective and efficient way where you need not waste much time on modeling. Okay, so that is also available with MIDAS GTS NX. So moving on to the presentation now. So these were the advantages. Just to summarize, if you see with the geometric input, you have strong modeling commands. You have automated features like automated auto connect and auto imprint types of functions. Then you have options, basic options with very important options like extract function, renaming it, construction stage wizard, which helps you complete the model very easily and very effectively. Then you have options like modeling wizards, which will help you deal with standard tunnel problems very easily. Okay, these are a few of the project applications where the software has already been used. So you will find that Dubai Tower, Palaces versus and D1 Tower. Then you have Inje Tunnel, Gungzhou TV Tower. Okay, so few of the renowned projects which I have just taken. Uh, and also it's being used for the pile raft design for pile raft of Kingdom Tower. Okay, because of the soil structure interaction capability between MIDAS Gen and MIDAS GTS NX. Focusing on few of the projects basically where GTS NX has been used from the tunneling point of view, I'm taking few of the projects. One is underground PC culvert, waterline connection to the shoreline duct, one of the done by Fresinet Korea. Daejeon Consultants, so Sosa Nongsan tunnels. So once again, GTS NX has been used. So investigation for stability of tunnels, shotcrete and rock bolts, by analyzing the stress concentration, and the transverse tunnel connection has been done. Similarly, if you see by Daejeon Consultants, same. Then ORM engineering. Okay, so if you, this is the problem we'll be taking in detail. So this new tunnel construction is taking place beneath major existing structures, so for which the stability must be ensured, and we'll be taking this type of problems in our upcoming session. So similarly, South Coast Highway expansion design for construction for 3D blast vibration analysis. By Dehan Consultant, you have the mine facilities where you have vertical shaft machine rooms. Okay, so this is all from my side. So to summarize today's presentation, we understood what a GTS NX is and what are its capabilities when we deal with real-time projects of tunnels. Okay, if you have any questions, you can always write to us at techsupport@midasit.com. This is our dedicated support email ID, where you can just drop us a mail and we'll get back to you. So thank you very much to all of you for attending the first session. Hope I was able to give you an insight about the program and its capabilities to deal with the tunnel problems. Thank you very much.